This is going to be, sorry, I'm moving around here. This is going to be page 2 of your chapter 4 notes, writing equations. This is just acid-base reactions. So we did double replacement reactions. This is just acid bases. So you maybe don't know a whole lot about acids and bases right now, but things are acids, obviously, if they start with hydrogen. Okay, but they're not acids until they get in water. Okay, so a thing that's an acid has the ability to donate a hydrogen. Acids can give away a hydrogen. So you put them in water, they have the ability to give a substance a hydrogen. Bases have the ability to accept a hydrogen. So acids can give a hydrogen, bases can accept. So in all these reactions, the acid is giving a hydrogen to the base. Okay, the acid is giving a hydrogen to the base. So it's always a hydrogen transfer. So for all these reactions, it's always a hydrogen being transferred from the acid to the base. There's 3 different types. Okay, we'll do strong acid, strong base, a weak acid, strong base, and a strong base, weak acid. We'll never do weak, weak. Reaction does not really occur. So first one, strong acid, strong base, is really a double replacement reaction. It's called a neutralization reaction because the acid and base will neutralize each other if they are in equal molar amounts. Results in a salt of some kind and water. So here's an example. Let's take a strong acid such as hydrochloric and react it with a strong base. So strong bases are family 1 elements with hydroxide, part of family 2 as well with hydroxide. So strong acid has the ability to give a hydrogen. Strong base. If we wrote the actual equation here, okay, we always want ions if they're soluble. That soluble splits apart into ions, 100% ionizes. That soluble splits apart into ions. Again, it's always the acid giving a hydrogen to the base. Always an acid giving to the base. So if we think about this, a hydrogen is being given. The hydrogen is going to form with the OH to make water, which I'll oftentimes write as hydrogen hydroxide, or HOH. Okay, but it is just water. And you have some sodium chloride left over. So notice we formed a strong acid, strong base forms a salt. In this case, it actually formed table salt and water. So if these were in exactly equal molar amounts, if you had exactly the right number of moles of these 2 things, you'd end up with some salt water. Now, this is not an anion equation. Actually, would not be an equation I would even accept. So this is split apart into ions. So you'd have H plus ions plus Cl negative ions plus sodium ions plus hydroxide ions. So all those things would be split apart. Water does not obviously split apart. Water stays together as a molecule. So we still have water plus sodium ions plus chlorine ions. Now look at our spectators here. Sodium, sodium, chlorine, chlorine. Our net equation is H plus ions react with OH negative ions to make H2O. That'll always be the case. For a strong acid, strong base, it's always just H plus ions plus OH negative ions make water. And your spectators would be your cations and anions that were in the 2 acids and bases at the beginning. So if we erase that, another example would be like if we had like HNO3 plus barium hydroxide, which is also a strong base. Strong acid, strong base. So what you'll learn here as we go, whenever you have a strong acid, the reacting species is always H plus ions in every reaction. So we can always ignore the anion part of it. And for a strong base, the reacting species is always OH negative. If it's a weak acid, the molecule stays together, so all of it's part of the reaction. If it's a weak base, all of it stays together, so it's part of the reaction. So again, your net ion equation there would be H plus plus OH negative equals H2O. Okay, so that's only true for strong acid, strong bases. Next one, weak acid, strong base. Okay, weak acid, strong base. So this is our base. It's got OH negative in it. Okay, that's our base. So here's our strong base. So the first thing I always got to do is identify what's what. This is our weak acid. Okay, so A weak acid, it's kind of a weird weak acid, it's acetic acid. I usually write acetic acid, instead of writing it like this, I usually write it as HC2H3O2, because I like having that hydrogen at the front. So maybe instead of writing, it's actually this hydrogen is being given, so maybe we'll use this instead. So that, let's use HC2H3O2. So that's acetic acid. Okay, so weak acids or weak bases stay together as a molecule. They dissolve, this dissolves in water, but does not split apart into ions. So you show, for the net ionic equation, you show the whole molecule together. Okay, to start with. That's a 3 right there, by the way. Reacting with a strong base. So if we think about it, this splits apart into sodium ions and hydroxide ions. It's really still a double replacement reaction. Acid is always giving a hydrogen to the base. So we still get water being formed. And you end up with some sodium acetate. But things with sodium in them are always soluble. So the sodium ions and the acetate ions are going to be split apart into ions. Water stays together as a molecule. If we get rid of spectators here, you have sodium ions. Acetate was not ions over here. It was a molecule. There it is ions. So two different things. Got to keep that involved. So our net equation would be right there. You can get rid of sodium ions as a spectator. Weak acid, strong base. So what you're kind of figure out is a weak acid, you always show the whole molecule. Strong base, you only show OH negative as a reacting species. You always get rid of the cation at the front of that. It's always going to be aqueous as you do things. There's your weak acid, strong base. Again, the acid is always giving a hydrogen to the base. Acid giving to the base. Right off. Last one, strong acid, weak base. Strong acid, weak base. So here's what I will show you. The only weak base I will use, okay, this is the most common weak base, is a derivative of this. Not ammonium, but the ammonia molecule. So this is ammonia, that's a weak base. It has the ability to take a hydrogen, so it makes it a base. It has the ability to take a hydrogen, which makes it a base. So anytime you see something with NH in it, okay, anytime you see something with NH in it, so you might see that, or you might see that. If you see this NH group in there, that thing is a base. It has the ability to gain a hydrogen. All right. You'll see this later in the year, but if you put that in water, put ammonia in water, it has the ability to take a hydrogen. So it takes a hydrogen, makes the ammonium ion, and now you have some OH negative. So the reason it is a base is it produces OH negative ions in water. So it's a base because it produces OH negatives. So let's pick out a strong acid. So I don't like my little example here. We'll do a strong acid. So let's say we have HNO3, strong acid, or HCl or HBr or whatever it is, plus ammonia. There's our weak base. Strong acid. Whoops. Weak base. Strong acid, weak base. Just like before. Strong acids, the reacting species is H+, so we can ignore the NO3 negative. Okay, it's a spectator, it's going to be there before and after. So for a strong acid, your reacting species is H+ ions. Anything that's weak, whether it's an acid or a base, the whole molecule stays together. Weak base, whole molecule stays together. This is the one time you don't make water. H+ ions plus NH3, again, the acid gives to the base. We're going to form NH4+, which is actually a weak acid in itself. A strong acid plus a weak base makes a weak acid. The acid's a little bit stronger over here. Another one you might see. So let's say we have some HCl plus, this is called methylamine if you've watched Breaking Bad. You're always looking for that. So again, strong acid the reacting species is just H+. Weak base, the reacting species is the whole molecule. Acid gives to the base, we form CH3, NH3, which now has a positive charge. It's gained a hydrogen, now has a positive charge. Again, this ends up being a weak acid. That's a little bit down the road as we go. Video's getting a little bit long here. Let me go to the last part here. Oops. We'll talk about this little chart and go over these in class. So I think I just have you try these. Dimethylamine, I will tell you, is this. Not that you would need to know this one. Okay, you don't need to know what dimethylamine is, but dimethylamine is so it is a weak base. Reacting with sulfuric acid, which is a strong acid. So try to write those three equations. We'll go from there. Have a good day.